Sensitivity. Sensitivity, finding by how much profit can change before there is a change in the optimum value. In plain English, what that means is, let's suppose that we find that this one here is the best vertex for us, and this gives us the production levels. If there's a change in one or both of the commodities, it may be that there's a switch to another vertex, and sensitivity is all about finding when this occurs. So we're going to look at this with example 5. A farmer has the choice of growing wheat or barley with the following conditions. So we can see wheat along here, barley up here. At least 30 hectares of wheat and 20 hectares of barley must be grown. So 20 hectares of barley, we can see that that's this constraint just here. 30 of wheat is this constraint here, so we need to be to the right of this one and above the dark blue one. No more than 100 hectares is available for planting, so that's this pink line down here. We have to be below that. That line gives us a total of 100 all the way along. He cannot have more barley than wheat. So this is the line where barley and wheat are equal. That's the line B equals W. He can't have more barley than wheat, but he could have more wheat than barley, so it's below this line. 180 hours of labor is available, and wheat requires 1 hour per hectare and barley requires 3 hours per hectare. So that looks like it's this constraint that we have listed here. You can see the other ones we've discussed. And so that's the final line, this sort of very light blue one. We need to be below that, and that defines this region for us. So the profit on wheat is $20 per hectare and barley is $30 per hectare. So that's going to give us a profit function equal to 20W plus 30B. So our vertices are 30, 20, 30, 30, which is clearly going to be better, but you still have to test all of them. Then we've got 45, 45, 60, 40, and finally 80, 20. So if we work out the profit by substituting in, W is 30, B is 20 for this one, then that's 1,200. This one's 1,500. Then we have 2,250, 2,400, and 2,200. So we can see this one is the best. So we're going to go for 60 wheat, and we're going to go for 40 barley, and that's going to give us a profit of 2,400. By how much would the profit on barley have to rise before a change in the optimum value occurs? So at the moment we're at this vertex here. It's the profit on barley that's going to rise, so we need to produce more barley, and that means we might need a bit less wheat. So what we're looking is, where is it going to switch to this vertex, the one that has more barley and less wheat? So if we increase the profit on barley, that's where the switch will occur. So what we're after is when the profit on 60/40 is equal to the profit on 45/45 under the new conditions. Now we don't know what the new profit on barley would be. So let's just call it something like K. Wheat hasn't changed, so our profit is now 20W plus KB. So substituting in here, that's going to be 20 times 60 plus 40K. And here we're going to have 20 times 45 plus 45K. And we need to solve this equation. So this is 1,200 plus 40K, and 20 times 45, let's just quickly do that on the calculator. Should be able to do it in my head. That's 900 plus 45K. So rearranging, 5K would be equal to 300. So K would be equal to 60. So that means that the profit on barley would need to be $60. So that's a rise of $30 from its current level of $30. We're now in a position to do the first 3 questions of exercise 2F.